Good evening, everybody. What we'll be doing for today's session is programming this robot using codes that we learned last class. This is what we built last class on the chassis, the motor, the caster wheel, and the wheels mounted on the chassis. We also learned programming our Arduino. I'm just shifting the screen to my camera here. Just give me a moment. Okay, so this is the robot that we did last class, the two motors and the Arduino board. What we'll need new is this board here, which is called the motor driver board, using which we will be translating the code from Arduino to these motors. We do understand that Arduino works on 5 volts and you will not be able to run the motors directly with 5 volts. You will need at least 9 volts for these motors, anywhere between 6 to 9 volts for these motors. So we use a motor driver that will amplify the signals given by Arduino to these motors. So I have a battery with me. The battery voltage is about 7.4 volts. I'm going to use this here. Let's see how the motor rotates. I'm going to connect it. So I connect the positive of the battery here. There's somebody here. Just give me a moment. All right. Yeah, so I connect the positive of the battery here and the negative of the battery, and you'll see that the motor rotates. I do the reverse, and the motor rotates in the opposite direction. The same holds good for this motor as well. And what I'll need is a programming cable for this Arduino board. I'm quickly going to grab the programming cable for this Arduino board. I just misplaced it somewhere. All right. Okay, so here's a battery. So we'll be working on these systems this week. So I'm just going to give you a heads up of how things will be and what program we would be writing. So I'm quickly going to open the Arduino program and see how we can program this. In the meanwhile, I'll make the connections to the motor driver. I'm going to bring these wires up through these holes here. The left motor and the right motor. And the Arduino board. Sorry, the motor driver board and the Arduino board here. So we'll quickly connect the wires to the motor driver board. So this part here is for the right motor. This for the left motor. This is where I connect the power supply. We're going to connect the power supply to this board. I have a connector for the battery. I'm going to connect the positive all right. Yeah. I have to connect the positive to this pin here. So you see it's written 5 plus 5V. Anywhere between 5 to 9 volts can be given to this pin. That's typically the voltage required by your motors to rotate. I am connecting the positive of the battery here. So turn to the right and the motor terminal gets tightened. And the negative terminal to this pin called 0V. Okay, I'm just gonna give you a clear picture here. Yeah, so this is plus 5V, whatever is written here is with motor supply. And this is 0V, which is the ground. And this is where I connect the battery. Now when I connect the battery, you'll see that the light glows. Why don't I just turn this around? Yeah, cool. Yeah, cool. So the light glows, which is an indicator that the board is working. I'm going to remove this connection. I'm going to connect the motor to this motor driver board. I'm going to connect the left motor to this terminal and the right motor to this terminal. The order in which you connect can be interchanged depending on the direction. All that will happen is the motor would go reverse instead of going forward. That then you can change the motor terminals to get it running in the direction that you want. So let's quickly loosen this part, turn it to the left, anti-clockwise. Same thing here. So you see that this thing opens up, and that's why I connect my motor. Now one thing you have to keep in mind is you'll see that there's a number 1 and 2. See, this is 1 and this is 2. And I'm connecting red to 1. I'll do it from here. I'll connect red to 1 and black to 2. And I'm going to tighten this. I'm going to do this here. All right. So once this is done, the connections are made. All that we'll have to do now is to power this and test the motors. Now, if you look closely at these pins here, I'm going to zoom in a bit. Okay, just became visible. Yeah, so it says five volts, ground, I1, I2, I3, I4. Now what I1, I2, I3, I4 is, give me a moment, let me just close this. Yeah, what I1, I2, I3, I4 is these pins here. This is the output of I1, output of I2, output of I3, and output of I4. Now, whatever I give here a signal to I1 is going to come here as O1, O2, O3, and O4. This is output 1, output 2, output 3, output 4. Left motor on one side, right motor on the other side. We know that there are 4 terminals for my motor, 1, 2, 3, and 4. So I1, I2, I3, and I4 is actually the signal that comes from Arduino. The signal that comes from Arduino to I1, I2, I3, I4, which controls these 4 pins of these motors. And then O1, O2, O3, O4 is the output that goes to the motors. So this board here amplifies these signals. So if I give 5 volts to I1, I'm going to get 9 volts here. Suppose I connect a 9 volts battery. I'm going to get 12 volts here. Suppose I connect a 12 volts battery. If I'm connecting 0 to I1, then I'm going to get 0 volts here, irrespective of what voltage I've given. So it's typically amplifying 5 to 9 and then 0 to 9. So you just increase the voltage. This is an amplifier board. We call this a motor driver board. It will drive the motors because Arduino by itself is not capable of driving the motors because the motors require more voltage to run, unlike the LEDs or the buzzers. The motors require at least about 6 volts minimum and will take a maximum of 9 volts. So Arduino is not capable of doing that. So hence, why am I having notifications? Hence, we use this motor driver board, right? Let's quickly go and see how these motor driver board work before I even program with Arduino. I'm going to check how this motor driver board works. I'm going to connect the power supply to this board. I'm going to put some wires here to I1, I2, I3, I4 using the supply that I have here. So this here, this pin is actually, it says plus 5V. You can closely look at it. Yeah, it's 5 volts. This pin here is an extra pin, which is 5 volts. And this pin here is 0 volts. I'm going to use those 2 pins to give values to I1, I2, I3, and I4. And then I'm going to change each of these to see if the motors are rotating. So back here. Okay. I'm going to quickly grab a wire. The wire that I would require is a wire like this, which has male pins on one side and the female pins on the other side. I'm going to connect one of these pins to 5 volts, or I would rather use a wire this way. It has both female pins on both sides. I'm going to connect one of these to 5 volts and one of this to ground to see how it works. I'm going to take, say, 5 volts and give it to I1. Observe what happens. Now this I know is output 1 and 2. Now I connect I1. You see that the motor is going reverse. When I connect it to I2, I see that it goes forward. The same thing when I do it for I3, I'll see that it goes reverse. When I connect it to I4, it goes forward. Which means when I make I1 high, the motor goes reverse. When I make I2 high, the motor goes forward. Same thing with I3 and I4. When I make I3 high, the right motor goes reverse. When I make I4 high, the right motor goes forward. Now what happens when I make both of these pins high? I take it to I3 and I connect it to another 5 volts here. You see that the motor stops. This is because both the terminals are now at the same potential. Hence, they will not rotate. The motor will not rotate because both these terminals are at the same potential. And I just take one of them out. By default, each of these pins are at 0 volts. And when I give them to 5 volts, here it changes. Now you can also see by the change in color of this LED. It's green. When I make it high, when I make both high, it becomes orange. And make just I3 height becomes red. So this one has to be programmed by the Arduino board here, either using one of these pins, like how we controlled LED, multiple LEDs. We control this motor driver board using 4 pins for I1, I2, I3, and I4. When I'm connecting this board, Arduino board, to the robot, since this will be powered by a battery, I will have to power up the Arduino board separately. For this, I will use these 2 pins here, which is 5 volts and ground. I'm going to take 2 wires from here and connect it to the power pins of Arduino. 5 volts and ground, so that the Arduino gets powered up. Let's power up Arduino board using these wires. And take 2 wires. I'm going to connect the yellow wire to 0 and the orange wire to 5 volts. I'm going to connect this here. The orange wire goes to 5 volts and the yellow wire goes to ground. Now you'll see that the light on Arduino will turn on. See this? Which means Arduino is now powered on. Whatever program is in Arduino is now going to run because of the power supply that I've given from here. All I have to do again is to connect a few wires from few of these digital pins. We need 4 pins to control both the motors, but we just need 1 pin, 1 wire to control either of the motors, just one, either one direction. So what I'm going to do now is just connect pin number 2 to I1. Right, I'm going to connect pin number 2 to I1. I'm going to leave it here. I'm going to now program my Arduino board. So I will need a cable for this. I'll just take the cable. The connection that I've made is I've just connected 1 pin from Arduino, pin number 2 to I1. The 5 volts and ground on Arduino is connected to 5 volts and ground on the motor driver board. And I have to connect battery to the motor driver board, which is connected, and I place the battery here. Okay, let's go ahead and quickly write the code to run this motor. The code goes like this. This is the last code that you've written. File, new. I'll go ahead and change, save. I'm gonna save file, save as. I'm going to motor test. Save. So I'll quickly go ahead and write the code. I'm sure you're aware of what has to be done in each of these steps. I'll repeat that again. 3 parts to Arduino code. The very first part is initialization. The second stage is setup, and the third is loop. In initialization, I would declare the pin in, I would say, right motor pin 1 is equal to pin 2. So, or I would rather say I1 is equal to pin 2. Okay, and here I would say pin mode I1 comma output, because I have to declare that pin as output pin. And here I would go ahead and say digital write I1 comma high. I'm going to upload this code to the Arduino board, and I will probably see my motor rotating. The right motor is here. Sorry, the left motor. Right. Okay. Okay. There's been some problem in the code upload. Okay. So I'm going to just change. This is I1, and I'm going to go to Tools and check if my board is detected. Yes, it's detected. Upload the code. Problem uploading to board. Just quickly check what's the problem. Okay, I think there's a little problem with my board. I'm just going to change the board for a moment. Just give me a moment to change the board. Okay, here's the board. I'm just going to change board to the new one. I'm going to just take this out. I'm going to connect the number 2 here and ground pin. I'm not connected the 5 volts pin here because I already have powered it to the USB. I need this board. All right. So let's see if we can upload the code now. Yeah, so I see that the motor is rotating. So if I make this low and upload the code, the motor just stops. Okay. Now, an interesting thing here is if I'm using I1, I'll be able to either make the motor go forward or stop, or go reverse or stop. I can only do 2 functions because it's a single pin. A single pin is capable of doing either of 2 things, either make it low or high. That gives me 2 options, either stop the motor or make the motor rotate in one direction. If I have to make the motor rotate in either forward or reverse and stop, which means there are 3 options. And because I have 3 options, I will need another pin to do, which means I'm going to configure another pin here in the program. So I'm going to say int I2 is equal to 3. Which means I'm going to declare pin number 3 and connect it to I2. I would say pin mode I2 is also output, and digital write I2 is high. You should always observe one thing. I1 and I2 is always complementary for the motor to rotate. If they both are the same value, which means either of them are low, if both of them are low, then the motor is going to stop. This is called dynamic braking. This is required when you have to stop the robot suddenly. We're going to cover this in the classes that will come in future. Now let me upload this code. and also go ahead and change the wires. So I have the board here. I'm going to take a wire from yeah, I've got the wire. I'm going to connect the wire from pin number 3 here to I2. So from pin number 2 to I2 is where I'm connecting. Now it's ready to rotate. This motor here is ready to rotate. I'm going to just lift it up a little and use a battery here and lift it up in there so that it doesn't make the robot go forward. So you're able to see it. Great. Now, let's quickly go ahead and upload this code and see what's happening. The motor here rotates in forward direction. So this is going in forward direction. If I make this low, since both the terminals will be at the same potential, the robot's going to stop. And if I make this high and this one is low, the robot's going to go in the reverse direction. And if I make both high, it's going to stop again. Now, another interesting thing is if you try to rotate the motor here, it's going to be very difficult because both the terminals here are at the same potential. So the robot will come to rest, which in fact is used when you have to stop the robot suddenly. So when you give high and high, the robot stops suddenly, then just removing the connections. If you have to stop your robot, you will have to make these pins high and high or low and low. Only then your robot will stop. Now, is there a way in which I could, now going forward, when I1 is low and I2 is high? Now, this could be for two reasons. The connection that I made here, that you see here, I could reverse this so that when I1 is high and I2 is low, the robot goes forward. Or I could change it here. Either ways, just by reversing the motor the battery terminals, which I mean the power terminals that's connected to the motor, will be able to reverse the direction of motor. Similarly, you could do it either here at the connections, or you could do it in the program. I could say this is 3 and this is 2, and then if I reverse it, it's going to work. Or I reverse it at the source. If this is typically used in cases where you have only options to change the program but not to rewire the entire circuit. So that I'm going to change here in the program with the numbers. All right, I'm going to stop this motor for now. I'm going to repeat this connections again. And this is what we would be doing in the coming class. Now we'll be doing with both the motors put together, and we would have the robots going in different directions. Now I've done this for one motor, and in the Hangout session we'll be just covering one motor. But if you're supposed to do it for both the motors, it's quite simple. I'm going to write the code for both the motors. It's going to be like int I3 is equal to 4, int I4 is equal to 5, and then I do the same thing here. I just copy this and gonna make this 3 and I4. And if I make this I1, I2, I3, and I4. Now when everything is low, the robot just stops. When I1 is low and I2 is high, and I3 is low and I4 is high, both the motors go forward. So the robot goes forward. So I would say robot forward. So this is robot stop. So if I have to make the robot reverse, I just have to reverse it here. Make this high, and make this low, and make this high, make this low. So robot goes reverse. Similarly, if I want the robot to go, say, right, I want my left motor, which is I1 and I2, to go forward, and I want the right motor, I3 and I4, to go reverse. Make it here. It's gonna be low, high, high, and low. So this is robot right. If you want to make it robot left, it's gonna be the reverse of this. It's gonna be high, low, low, and high. Now we've already written about 50 lines of code. This only to make your robot say stop for say 1 second, and then make your robot go forward for a second, and maybe make your robot go reverse for a second, and make it go right for a second, and turn left for a second. The robot just stops, goes forward for a second, goes reverse for a second, turns right for a second, and turns left for a second. So this is what's going to happen. This is how you navigate with your robot. You're going to see this practically in our classes. We will record a video and attach it to this Hangout once the class is done. So this session is primarily to introduce you to the motor driver board, which amplifies the signal that comes from the Arduino board. We give it I1, I2, I3, and I4. We also use these two pins here, which is 5 volts and ground, to power up my Arduino board. Because once I remove it from the computer, I still want the robot to run. So that's the reason I would do it. And then whatever you give it to I1, I2, I3, and I4 gets amplified and comes here to O1, O2, O3, and O4, which is output 1, output 2, output 3, output 4. Output 1 and output 2, I connect the left motor. Output 3 and output 4, I connect the right motor. When I1 is high and I2 is low, the right motor goes reverse. It all depends on the connections here. In case you reverse this, the robot will go forward when I1 is high and I2 is low. The same thing with I3 and I4, which happens with the right motor. And this is used to control the robot. So by this class, this Saturday class, we would be able to control the robot, be able to make it go forward, reverse, right, left, and all of that. And the next coming class, we'll be making speed control, so like changing the RPM of your motors using analog write. This we discussed last class, using analog write so that you could vary the brightness of LED. Similarly, using analog write here would vary the speed of this motor. And this is it for today's class session. And we'll catch up next week with yet another design class, because next week is going to be design. We're going to have designing a chassis, and then we will also be giving a demonstration on different manufacturing techniques. Thank you for being part of this session. See you all. Have a good week ahead. Oh, I have a question. I have a question, so I'm going to just take the question. All right, but how will we move the robot? Okay, I'm gonna stop my screen sharing. All right. Yeah. So how the question is, how will we move the robot and stop it without our laptop, because Arduino is needed to change to high or low? Do we have to run behind it? No, you don't have to run behind it. We just the moment I disconnect, you see that it's still turned on, and all I have to do is connect the 5 volts and ground from Arduino to the robot. So it's right here, 5 volts and ground. And let me just upload this code. I'm gonna do this for like one motor. I'm gonna screen share my camera. I present it to everybody. All right. So when I upload this code, the problem uploading. Oh, yeah, I have not connected the. Just give me a moment. I'm just gonna make the connection. So you'll see it goes forward for a second, stops for a second, forward for a second, reverse for a second, and then turns right and then left. Now, because I've not connected the other motor here, okay, why don't we just go ahead and connect the other two as well? So I'm just gonna grab 2 wires and gonna make the connection. So connected to 3, and I just need another wire. All right, 2. Trying to get a wire, and yes, I got a wire. Sorry, I'm not able to find a wire that can actually fit in. Yes, I've got a wire. So I'm going to connect it to I2, I5. I made the connections here. It says I1, I2, I3, I5 to 2, 3, 4, 5. I'm going to make these connections here to the robot, and you will see that okay, the code that I just wrote, we see that goes forward, reverse, right and left, and stop. Forward, reverse, right and left, and stop. So it's forward, reverse, right, left, and stop. Forward, reverse, right, left, and stop. Forward, reverse, right. Okay, the wires come. Okay, so we're gonna. So this is what happens when you are programming it. I just remove the connection. All right. So this is the code. Have a look at it, and we're gonna see you next class. Until then, bye bye. How do we change when it's moving? Tanish, if you have to change when it's moving, you will have to either use a remote control, because you will have to upload the code. If you have to upload the code to the controller, then you will need to connect it to the computer. So that For that, we will use a remote control, either Bluetooth or RF or one of these controllers to be able to change. So what we do is, we would say if the command is A, then make the robot go forward. If the command is B, make it go reverse. If it's C, make it go right. If it's D, make it go left. So that's what we will do. And this is important because we will be learning about how to control your robot using your computer and even without your computer. So this will come in future classes, but for now you can only program it to do one function, a set of functions, and it will do that forever in a loop. All right. Thank you. Can I exit the broadcast now? Thank you.